Alright, let me introduce the concept of a derivative by using an example. Here we have y equals to x squared graph. We all know that it's a parabola. And let's say you have a point 2, 4, and you want to find out the equation of the tangent line. Now, because the line equation is y minus y naught equals to m times x minus x naught, that's called the point slope form, and we know that it passes through 2, 4, I can write y minus 4 equals to m times x minus 2. Now, however, in order to get the slope m, we have to ask ourselves, what makes this tangent line special among all the possible lines that you can draw that passes through 2, 4? After all, this is a line that passes through 2, 4 with some slope. So in order to figure out what slope is appropriate for our answer, we have to ask ourselves, what special property does the tangent line satisfy? And one thing that you can observe is that if you draw any other lines, then these other lines will meet with the parabola twice. Right? And tangent line is special in the sense that it meets only once, right? Now, when I ask students what is the definition of a tangent line, a lot of the students say, oh, it's the line that meets with the graph only once. Well, that's only true in this case. In general, a tangent line is a line that that's closest to the graph at that given point. Okay, I'll probably be able to elaborate that later on when I do the second method. Okay, but for now, for the first method, what we want to use is that the tangent line is the line that will pass through the quadratic function only once. Okay, it's going to meet only once. Now, to use that property, let's first simplify this by multiplying m out. So it's mx minus 2m, and 4 is added, just like this. And then think about how we can figure out the point of intersection. How do you find the point of intersection between two graphs? Well, you set them equal to each other. Here's y equals x squared. Here's y equals mx minus 2m plus 4. I know this is a bit scary because you have an m here, but nonetheless, since we're trying to find the point of intersection, and we're trying to find out how many we have no choice but to set them equal to each other. That's the first method. Okay, let's try to solve this. Okay, we have to find the intersection point, we have to solve this for x. To solve this for x, since this is a quadratic equation, we should move everything to the left. So we have x squared minus mx plus 2m minus 4 equal to 0. Okay. How do you solve a quadratic equation? You use the quadratic formula, right? So you say x equals to negative of negative m plus minus square root of negative m squared minus 4 times 1 times 2m minus 4 over 2 times 1. Because a is 1, b is negative m, and c is 2m minus 4. And if you forgot the quadratic formula, it's negative b plus minus square root of b squared minus 4ac over 2a. Okay. Hopefully you remember the quadratic formula. There's a song that some people sing, x equals negative b, something like that. It ends with all over 2a. I refuse to sing the whole thing, but you can figure out what it is. Okay. But anyways, it's negative b plus minus square root of b squared minus 4ac over 2a. And this part here, let's think about this. If this is non-zero, how many solutions do you have? You have 1 plus this thing and 1 minus this thing. So you have this thing plus and a minus of this quantity here. So if this is a non-zero quantity, you'll have two solutions. Just like if you have a solution like 3 plus minus square root of 5 over 2 or something. If you have an equation, quadratic formula giving you a solution like this, it's actually two solutions because it's 3 plus and 3 minus, right? Just like that. If this is non-zero, then you're going to have two solutions. But that's not good. What do you want to have? We only want one solution. How can that be possible? Only when this thing inside is 0. Then adding a 0 or subtracting a 0 doesn't give you two different numbers, right? That's how it works. So we conclude that to have only one intersection point, this m squared minus 4 times 1 times 2m minus 4 has to be 0. Let's see, m squared minus 8m plus 16, it should be 0, and this actually factors as m minus 4 times m minus 4 equal to 0, and therefore m is equal to 4. Alright, and now we just plug m back in, and you get y minus 4 equals to 4x minus 2. I should have wrote down the question. The question is, what's the equation of tangent line? And the answer is that it's y minus 4 equals to 4 times x minus 2, and if you want this to be slope-intercept form, you can solve this further. Okay, so that's method 1. It's pretty long, but it doesn't use any kind of limits. Now let me show you how this same question can be solved using limits. And hopefully after the second method, you will really appreciate this approach by limits, and you'll be sold on the idea of the derivative. Okay. All right. In the beginning, it's the same. We're still looking for a tangent line equation, so you still write down the point-slope form. Here's the point-slope form with 4 and 2 plugged in, 2, 4 plugged in, and then then we again think about what m is. So we really need to know the slope. Okay, to find the slope, let's think about the slope formula. Slope is change of y over change of x, right? And where y is like, if you're given 2 points, it's like y2 minus y1, and delta x is, if you're given 2 points, it's x2 minus x1. So change of y, change of x divided, it gives you the slope. Now for us, that's not so useful because we only have 1 point. However, there's an idea of approximating this slope by picking a nearby line. So instead of this 2, 4, why not choose another point right here, which connects these two? Right? So that's a secant line. That's called a secant line. It's not a tangent line. Where if this is 2, you're just off from 2 by a very small step called h. Let's say this interval is h. H is pretty small. And if you go slightly to the right and evaluate this function, so since y is equal to x squared, if x value is 2 plus h, then if x is 2 plus h, that means y is 2 plus h squared. So So you have the coordinates 2, 4 here, and here 2 plus h, 2 plus h squared. And then we can find the slope, which should be pretty close to the slope of the tangent line we were trying to draw, right? At this point, you might say, "Oh, that's just an approximation. How does it help us?" Well, it will be the limits that will help us. Okay, so let's try this. We have 2 plus h, 2 plus h squared as this nearby point, and 2, 4 as the point given to us. Subtract 2 plus h minus 2 is h. This one is pretty complicated. I'll just write it as like that. So what is this? This is a change in x, and that's a change in y. So we have slope m equals to change of y minus 4 over change of x. So that's the slope of the secant line. Now, this approximation will get better and better as this difference between 2 and 2 plus h narrows down. In other words, if h becomes closer and closer to 0, this approximation will be closer and closer to the slope of the tangent line. In fact, at the limit, it should become the tangent line, right? It should become the slope of the tangent line. So let's try that. Limit h going to 0 of 2 plus h squared minus 4 over h, which is equal to limit h going to 0. Now you can FOIL this out if you write this as 2 plus h times 2 plus h. You FOIL it out, you're going to find it's 4 plus 4h plus h squared minus 4. You might be wondering where 4h came from, but if you carefully FOIL this out, you're going to see 4h. Okay, so 2 squared will give you 4, h squared will give you h squared, but 4h will come out if you FOIL this out. Okay, 4 cancels, and now you can split this fraction into 2, right? You can write this as limit h going to 0 as 4h over h plus h squared over h. Right? Some people call this share the love, but it's like a heart shape, right? But it's just a simple fact that if you have two fractions with common denominator, then you can combine them, and if you combine them, you'll get that, right? And therefore, since this is equal to that, that should equal to this. Okay. Now, what is that? That's h cancels to give you 4, and h squared cancels, so it's really 4 plus h, and if you send h to 0, what do you get? You get 4. And if you recall, that's exactly the same answer that we got from method 1. Okay? In method 1, we had to deal with ugly quadratic formula, but here we kind of got the answer in a much easier way, although the concept behind it was pretty hard to grasp at first. So that's what derivative is. Okay? And in general, if you see what we did, you can make this into a general formula. If you have a function f, y equals to f of x, then here's point A, and let's say you have h away from A, so it's a plus h. Then if you evaluate the function at 2 points, a and a plus h, this point will be a comma f of a, because you're plugging in a into x. Right? And this other point will be a plus h comma f of a plus h goes into x. So these are the 2 points. And then when you subtract them to get the slope, f of a plus h minus f of a is the change of y, and a plus h minus a cancels, so change of x is h, and therefore the slope of the secant line connecting the two is limit h going to 0 of f of a plus h minus f of a over h. And that is going to be called the derivative f prime at a. Another symbol that people use is dy over dx at x equal to a. This means at. Now, this is called the Leibniz notation. Where does this notation come from? Well, this is really the slope, right? This is change of x, that's change of y, and we're getting the slope from change of y over change of x. And because this change of x is really the h, this h is change of x, and you're sending change of x to a very small quantity, you're thinking of this capital delta becoming this lowercase d. So this is like inheriting its symbol from its origin. And it later turns out that this way of thinking gives you a lot of benefits, so that's also used. Okay, so this is called the derivative. That's the definition of the derivative at x equal to a of a function. What's the meaning? Its meaning is that if h gets sent to 0, then gradually it goes down to 0 so that you get the slope of the tangent line. Okay? So the meaning of the derivative is, this has the meaning of slope of the tangent. Now the second meaning is, if you look at it like this, you're trying to measure how much y changes as you change x, right? And this will be called the average rate of change from this, as x goes from a to a plus h. But if you send delta x to 0, then you're decreasing the window down to 0, and that's also called the instantaneous rate of change. Instantaneous rate of change. Some people just simply call it rate of change. So if you see some word problems that asks you find the rate of change at a certain given time or given point, it's asking for the derivative. So you're going to see more examples of computing this limit.